All right, so hopefully online y'all are seeing my board now. So 2.3 goes back into a little bit more stuff on the domain. So this is finding the domain and range. So y'all, the very first one, I'm going to draw a picture up here. Because everything I got asked from this one goes off this picture. So I'm going to go out about 2, 3, 4, 5. I'll go out about 6. All right. -1, 1, I got a dot. -2, 2. -3, 3. And then at -4, 4. All right, I got dots over here at 0, 2, 1, 3, 2, 4. Okay. So everything they're going to ask me is off this graph, right? So I'm going to have 4 parts to this: A, B, C, and D. A, they want me to find f of -3. B, they want the domain. C, any x values for which f of x equals 2. And then D is going to be the range. So y'all going to use that graph to find all that information. Are y'all hearing me all right online?
Yes.
Yes.
Okay.
Yes.
I'm trying to talk a little louder because it may have to go through you a little bit. So f of -3, remember, when I put a number in for that x, that's telling me the x value that I'm using, right? So what this wants to know is, what y value or what output do I get when the x is -3? So for that problem, I'm going to find -3 on this x-axis, and I'm going to go right up and catch that point right there. So they're giving me the x, I want the y value. So y'all, what's the y value at this point? It is a +3. So f of -3 is going to be 3. So they give you the x, you find me the y value, okay? So the domain. The domain is the set of all x values. Okay, so my x values are all these x values that got a point above them. So I'm just going to go left to right, but it don't matter what order you go in. But I'm just going to go left to right. So it looks like my first x value was, now MATLAB's going to give you all the fancy little parentheses. So my first x value I'm going to put is -4. Then I got one here at -3, -2. I got one here at -1. This point is at 0. This point is at +1. And then my last point is at +2. So I just went left to right, found all my x values. You can go right to left, it don't matter, okay? So here's the one that's been giving people fits. Any x values for which f of x equals 2. It's pretty much the opposite of this question. This question, I gave you the x, you found me the y value. This one, they're giving me the y value, and we want to find those x's. So MATLAB will give you this. They'll give you the x equals. So f of x equals 2. That means that 2 on this y-axis. I want any points that are touching that line at 2. So give me the next value. Well, that's hitting right on it, right? So that X value is
-2.
Right? Now, this point was also at 2 on the Y value. Its X value is
0.
So y'all see the difference on these points? This one, they gave you the X, you found the Y value. This one, they're giving you the Y value, you're finding me the X's, okay? So now, what about my range? So if y'all remember the other day, I said the range was all the Y values. Remember, the Y values are going up and down, right? The smallest Y value is this point right here. What's its value? 1. So they'll give you them fancy parentheses again. All right, here's my next Y values.
2.
And they're at 2. There you go. Now, do you have to write 2 twice? No, because 2's in my domain or my range. I don't have to write it but 1 time, y'all, okay? What's next? 3. And then 4. And that's the highest one, right? So at 4, I close my parentheses and we're done. So they're just getting used to y'all knowing your domain versus those ranges, okay? All right, question on that. Now I'm going to do one with actual straight lines on it, okay? So let me see, I'm going to draw that line here. Well, wish we could draw these graphs, y'all, I ain't gonna lie. Think that when we hit 2.4. All right, so this one, I'm going to go out at least to 7. And of course, they all got the little arrows on them. All right, this line looks like a V like the absolute value line did. My first point is over here at 5, 0. Okay, so I'm gonna have to be careful on this. So this one has a line coming out like this. And then left is crossing right here. And the one out. So almost like the absolute values going in both directions. They still want to know 4 things. They want to know A, F of 2, B, domain, C, any values for F of X is 1, but I'll write them when I get room up here. So y'all, I need to know what is F of 2. So notice, they're giving me the X value. I need the Y value. So let's see, here's 2. So if I come up, so if I've drawn this really nice, it should have came right across at about a 3.
3,
So
man.
F of 2 is definitely going to equal
3.
3 for us. So when they're giving you F of 2, they're giving me the X value. So what I did, I came on the X-axis and found where 2 was, and then I went straight up to see where I was going to hit that graph line at. So since I hit the graph right here, I went straight left and see what that Y value was. Okay? So find your X, get the point, and then see where that Y value is. Okay? All right, last name? Okay. Is it Monica? Yeah, I should be getting good on you by now. I'm about to learn it. Give me another day or 2. My domain is all the x's that are in this graph. You know, this graph looks like it's heading to the left for sure. That's what that arrow's telling me. This arrow's telling me it's headed to the right as far as it can go. So basically, my domain is all real numbers, right? So when you got continuous lines like that, everything's a point on that eventually.
So if it's all real numbers, does that include like negative at all?
Because my x's can't be negative over here. See
Oh,
my-
yeah, okay.
Now,
Okay.
I see where you're going, but the range will be different.
Okay.
Okay. But as far as my x's, those arrows go both ways. So that would be all real numbers. So MathLab, it says domain is all real numbers. Okay, so here comes the tricky one. So y'all part C wants to know any x values for which f of x equals 1. So x values for which f of x equals 1. So y'all remember, Kevin, on that, and I found my x, then found my y for the a. Now, I'm going to find the y value that has a 1 and see what x's give me back. So y value of 1 is right here, right? So let's go across here. So I'm going to have this point right here. And if I go across, that point right there. So I need those two x values. So y'all, that's pretty close to 4. So I would have x equals 4, and then I got another one.
6.
X equals 6. So that's the trick on that one, y'all. Just find the y value and see what x's had that y value. So notice, A and C are pretty much opposites of each other. A, I found the x, went to get the y. C, I found the y's to get the x's. So now, you ready for this? The range. Can the range be negative?
It doesn't look like it.
It don't look like it to me, because remember, the range is my y values, and the smallest y value I got is 0, right? On the y-axis. All these negative y's I'm not even playing in. So, in MathLab, we'll have our fancy little parentheses. And then it'll say, oh, did I put the y equals? Yep. The y in the bar. Remember, the bar means such that. So the variable is y such that y is what? What's the smallest y value I got?
0.
0.
After going up in all them positive numbers.
Mhm.
So could we not do this? Y has to be greater than or equal to 0.
Cool.
Now, if it went down, I'd probably put y as less than or equal to 0 if it was on the bottom side of that graph, okay? So remember, domain technically reads from left to right. The range technically reads from bottom to top, okay? Y'all seen negative infinity stuff before and infinity? And this one goes down towards negative infinity, and this one goes towards positive, okay? All right, so the first two y'all have are going to be really similar to these two. Now let's talk about range of a function. I mean, not the range, but the domain. Well, I've been saying this stuff too much tonight. Now, we found domains off of graphs, right? But we want to find the domain of a function. So here we go. Finding the domain of a function. And don't know if y'all remember, but Monday there was only two things I said I was worried about when I found a domain. One was radicals. Right, y'all remember radicals? Now we won't mess with these in this section, but remember, a radical, I can't take square roots of negative numbers. If you try to take square roots of negative numbers, you get imaginary numbers, right? So when we get chapter 5, radicals will be in play. But for this section, I'm only worried about stuff like that. Can I divide that? No. Anything divided by 0 is undefined. Y'all remember that? Mm-hmm. So I'm definitely worried about fractions. So if I got a fraction with a variable in the denominator, I got to play with it to see there might be numbers I put in that make it undefined. So if there is, I got to kick them out of my domain. Because you can't graph something that says x value 0, y value undefined. You know where to graph that, right? So later on, I will show y'all that when that happens, we get what we call holes in the graph, or we get what we call vertical asymptotes. Y'all remember that word? No. Y'all will about a month. About a month, I'll get y'all on that and then how about that. So here's the thing. The domain of a function is all real numbers unless we have a fraction with a variable in the denominator. So if I got x's in the bottom, I'm worried. Now, if I got numbers on the bottom, it ain't bothering me because if I got a 2 on the bottom, no matter what I put on top, it's going to divide by 2. What I got to worry about is the ones where I put numbers on top and try to divide by zeros, okay? Now, we'll tell you in this section, you're only going to get one number that you got to kick out of your domains. But once y'all learn how to do a little bit more factoring and solving quadratic equations, then we can move up and possibly have 2 or 3 numbers you got to kick out. Y'all remember factoring? You always came up with 2 factors usually, and then set them to 0 and did all that fun stuff. I'm doing all that fun. Oh, you're going to get full today even. Fine. All right, so here's the case. If I do have a fraction, here's what we do. So if a fraction, and it means with the variable in the denominator. So if you got a fraction with the variable in the denominator, the first thing you're going to do, do we even care about the top of it? No, it can be 0. The thing we're worried about is that denominator. So set the denominator. Not equal to 0, because it can't equal 0, right? Now, when I solve the not equals, it's the same as solving what the equals on it, okay? Exclude all solutions. So if I set that to my 0 and I solve it, whatever answers I get, I'm excluding from my domain, okay? All right, so I'm going to work one and sort of show you how you would actually write those answers in that fancy parenthesis, okay? So y'all, on these problems, first thing I'm looking for, do I got a fraction? If I got a fraction, I'm going to worry about setting the bottom and finding it. If I don't have a fraction, I'm going to put all real numbers and move on to the next number, okay? All right, so these are actually going to be called find the domain of the function. right, so this starts at number 3. So those other two was 1 and 2 for y'all's work. I got f of x equals 13 divided by x minus 3. Well, guess what I do have? I got a fraction.
Yeah.
So we do have a fraction. So since we got a fraction, we got to take the bottom of this, which is x minus 3, and set it not equal to 0. Now, you don't have to use the not equals. You can use the equals on these. It don't matter. All right, solve that and be done.
3.
You're going to add 3 and be done with that, right? So x cannot equal a positive 3. So now in MATLAB, they're going to give you this, and they'll give you that. Usually on these, they've got like multiple choice questions. So y'all watch this. X is a real number. So it's got to be a real number. You can't put in imaginary numbers on these, okay? So it's got to be a real number. And we said x cannot equal 3. So basically, you're just putting in this part. You'll find which one has this and then put in a not equals 3 and be done. Now be careful. Some of them put equals 3 instead of can't equal 3, okay? And then they put 0 there, trying to mess you up because you had to set it to 0. Okay? Kind of silly that, is it? All right, here we go. P of x equals 2x minus 5. So you doing anything to that?
Yeah.
What's up there?
Set it equal to 0, right? Or not equal to 0.
Well, I would if it was a what?
Fraction.
Fraction. Do y'all see a fraction?
Isn't it all real numbers?
Oh, bam, there you go. Because remember up here we said, hey, the domain of a function is all real numbers unless we have a fraction. Well, I ain't got a fraction. All right, so this is going to be x such that x is a real number, right? And I don't have no restrictions, so x is a real number. So online saved y'all on that.
Yeah.
Question on that? I'm gonna up it up on this one. Turn up the heat. I can't turn it up too much on these. There's a fraction or anything. Well, how about this? P of x equals absolute value of x minus 5. So what y'all doing to that one? Well, I didn't have no restrictions on no absolute values, did I? Any number you put in there, I can take absolute value of, right? Whether it's a fraction, a decimal, a whole number. So since y'all don't see no fractions, my domain is all real numbers. Oh, I think this one was R of x all right, y'all, guess what? That is a fraction. So now y'all can tell me what to do.
2x minus 3 is not equal to 0.
Perfect. And I'm going to solve that, get my one answer, and kick that out of my domain, okay? Do y'all remember how to solve these?
We would add 3 to
had 3. So now it's telling me that the 2x cannot equal 3, because if 2x was 3, 3 minus 3 will make it a 0. All right, one more move and I'll be done with that.
It's like 3/2?
5, 2.
Divide by the 2, there you go. So x basically cannot equal a.
2/3.
So here we go, we're gonna write that. And basically, if they're fractions, they're gonna follow this pattern. If they're not fractions, they're gonna follow that, okay? So x such that x is real and x cannot equal, let me get a 3 over R2. Okay? So y'all, that's what 2.3 is gonna have you do. Now I will tell you, later on in life, y'all might have done real numbers as negative infinity to infinity at one time in life. Interval notation. We will do that later on. So we're just getting y'all used to the basics, just using set builder notation. Oh, here comes the fun stuff though. This is the algebra, 2.4. And he was talking about forming a while ago. So guess what? We're going to be doing a little forming. And a little bit of combining like terms. All right, y'all, so 2.4 is actually called the algebra of functions. Okay, so this first thing is sort of like a set of guidelines for you, okay? So up here it says, given f of x and g of x. I got 4 things that can happen here. Well, hell, I got 4 operations I can do, right? I can add them. I can subtract them. I can multiply them, and I can divide them. So those are the 4 operations that we can do with functions too, okay? So notation time, f plus g of x. And they really want y'all to know what this stuff means, but when you see something like this, f plus g of x, that's just going to be your f of x plus g of x. And when you add, the only thing you can do when you're adding 2 functions is combine like terms, right? If they don't look the same, I'll leave them alone and move on. Next, we'll do f minus g of x. You know, that's what, f of x minus g of x. Between those 2 operations, y'all going to miss more questions on subtraction than you will on addition. And that's just because of this. Let me just show y'all why. So I had 2 functions. So I had a function x squared plus 3x. And I'm subtracting, say, 5x minus 2. The reason I get y'all on subtraction is because y'all don't like to distribute the subtraction to everybody. You can't just subtract a 5 and then bring down a -2. Because you're not subtracting, you're not adding a -2, you're subtracting a -2. So when you subtract a -2, this makes it a positive 2. Okay?
So don't it changes all the signs inside their parentheses?
If this is positive, it's coming out negative. That's negative, it's coming out positive. So that's why I get people on those. And when they start out, they don't like putting them in parentheses, so they don't know who's getting carried through, okay? So remember, you're not just subtracting the first term of that function, you're that whole function, right? So we got to remember that on those. F times g of x. So f times g of x. This is the ones where you're going to FOIL, or you're going to do the distributive property or some kind of multiplication, okay? So this will be f of x times G of X. Now, we'll say the book likes to use dots. A lot of times it just puts the parentheses right next to each other. Very seldom will they use the X for multiplying because they got X's as variables and they don't want y'all getting them all mixed up. Okay. So yeah, this is where we might do a little fooling. So hopefully y'all remember those exponent rules for multiplying. Then what's my last operation you said was division logo, right? So F divided by G of X is going to equal my F of X divided by my G of X. There's one number G of X is not going to be able to equal. So G of X cannot equal what number? 0. Because if it's a 0, that makes all this undefined. Okay? So y'all, we got 4 operations, and basically they just want you to know that F plus G of X is your F plus your G, add like terms and be done. Subtraction, the same thing, okay? So y'all ready to work them? That wasn't really a loud guess, but okay. It's still new, y'all are still a little gun shy, right? Mm-hmm. When y'all get your confidence up, then everybody will be spitting them out quick, right?
Right.
All right, y'all, so here's how these will start. So you'll be given 2 functions. F of X, for this one equals X squared plus 2. G of X is going to equal X plus 3. They want me to find F plus G of X. So I'll tell you, usually when I do, I know sometimes you could use too many parentheses, but to start these, I'll start out by putting my functions in parentheses. So here we go. F plus G of X is going to equal my F of X plus my G of X. And I'm just going to put what functions go to each, right? F of X was X squared plus 2. G of X is an X plus 3. Even if I'm multiplying and all that, the only time I might not use parentheses is maybe when I'm dividing. But it's understood that the top is in parentheses and the bottom is in parentheses when you're looking at fractions. So since these are being added, I'm going to drop the parentheses because I don't have to worry about no signs, right? Not like that subtraction. So I'm just going to start with X squared plus 2 plus an X plus 3. So these are basically like distributing a positive 1. But my question was, can I even go further? Is there anything y'all can do to that? Yeah.
Yeah.
What y'all doing to this?
Combining the lifetimes,
Which are?
the X squared and the regular X will be.
Are those like terms?
No.
Oh, those ain't like terms. X squares don't look like X's.
Oh.
Quarters don't look like nickels.
Oh, no, you can't. So we'll add the 2 and the 3.
The 2 and the 3 is it. Yeah, because that'd be like a nickel, square would be a quarter. So remember, those are not the same. So exponents do got to match on them variables to be like terms. So she's going to add the 2 and the 3. So I'm going to get an X squared plus the X plus 5. Can y'all go any further?
No.
No, so now we're going to stop. Okay? Don't worry, y'all always try to turn my X's into X cubes on the first day. Y'all good? Oh, on this part right here? Okay, so here's the thing. They wanted me to find F plus G of X, right? So what I was doing right here was basically going back to the 4 rules I gave you a while ago. I knew F plus G of X would be my F of X plus my G of X. So what I did is I'm just filling in for what F and G were. So the first part, you're just putting them in there to add, right? At this point, since you're adding, I dropped the parentheses and everybody's sign stayed the same. Now, once I got to this point, the only thing I can do at that point is add like terms. So we went through, one of them can add to this x squared, right? So I brought it down. One of them can add to that x. There's no other x's, right? So I brought that down. The like terms were the numbers here, right? So all we did was say, okay, I got like terms, so I'm going to add 2 and 3 to get a 5. And then I'm done. I got plenty of these. I'm gonna get them in there. You watch.
I have a question. Would it have been considered wrong if you put it in a different order?
No, I just usually do what I call descending order on my variables. I start with my highest exponent, then my next, and then my numbers.
Okay.
But you could have put, if you went in order, you could have put, oh, hell, I got an x squared, 2 plus 3 is 5, and then I got an x. Okay. Unless Math Lab specifically says answers need to be in descending order, ever how you want to, okay? All right, here we go, Ken, watch this. This one I'm giving f of x equals x squared minus 4. G of x is going to equal x minus 2. They're giving you that. And they're even going to ask you this. They want you to find f times g of x. So they give you all that. So the actual problem is doing this, f times g of x, right? So I'm going to come down and write what that means. F times g of x means I'm going to have an f times a g. That's what I said, well, I'll go on them 4 things, right? So what am I putting in place of the f of x in the first parentheses?
X squared minus 4.
The x squared minus 4, which means the what? The x minus 2 goes in the second parentheses. So notice, I got f of x times g of x now. Guess what I'm about to do? I'm not going. Now, it really means first, outer, inner, last. But basically, they're saying, hey, take the x squared, distribute it over here. Take the negative 4, distribute it over there. Okay? So I'm going to do the first, which is the first ones from each parenthesis. Now you can do this. You can do the x squared times the x and make that a cubed, x cubed. And y'all, since this x didn't have an exponent, it was technically a 1. And all I'm doing is adding those exponents when I multiply variables. Now, the x squared also is going to get distributed to the negative 2. So x squared times negative 2.
Minus 2x squared.
That's it. So that takes care of the x squared being distributed. Now we're going to distribute that negative 4. And that's the all part, the OL, right? So how about negative 4 times x?
Minus 4x.
And finally, negative 4 times negative 2.
Plus 8.
There you go. All right, so next, what would I do?
Combine the like terms if they're even.
Is there any?
No.
No. X3's only add to x3's, x squared's only add to x squared, x's only add to x's, and numbers only add to numbers.
In math labs, are we going to be required to simplify it if it is simplifiable? Like you say, they're all divisible by 2. And there's a 2 in front of that x cubed.
Well, not on these, you don't have to worry about that. But if I was not solving equations, yeah, you want to simplify them.
Okay.
Because on this one, technically, I can't do nothing because I don't have nothing on this side.
Oh, yeah.
So if I wanted to divide this side by 2, I'd have to do that to this side, remember?
Yeah. Forgot it.
So, because we're just mainly dealing with expressions instead of equations. That makes sense, Chuck? All right, here's the fun one. No, but it ain't like that, not like that, okay? They just trying to throw a curveball, how about that? All right, f of x equals x squared minus 3. G of x is going to equal x minus 1. They want me to find G times G of x. So notice they might write these different. They might put two G's next to each other, which still means multiplication. They might use their little dots. Okay. So what in the world do you think they want me to do with a GGX? All right, so let's watch this. We're going to go down here and say, well, G times G of x is going to equal G of x times G of x. So the reason this is the curveball, they give me an f of x, and guess what?
Don't need it.
I don't even need it. So in place of both of these, I'm going to be putting
X minus 1.
x minus 1. Okay, so that's G times G. F times F, I'd have done the x squared minus 3, x squared minus 3, okay? So once again, we get FOIL. But I like this one because you got to do a little bit more work than just FOIL it, okay? So x times x.
X squared.
I got the x squared. X times negative 1.
Negative x.
Now, I will say, if you like to put the ones there, MATLAB will let you put the ones there. Sometimes. Sometimes it'll tell you, although your answer is correct, it's not in the right form. So if I see something like that, I'm thinking, oh, I better multiply the 1 and x and just make it an x. Okay? So it don't like ones in front of variables a lot. It don't like exponents that are 1 because x to the first is just an x. So watch out for if it does. If you're right, just sort of look at it and say, well, what could I do to change it, but it still stays the same value? Okay? And especially never put a 1 on the bottom as a fraction. Because if you do like 2 over 1, it's like, oh, the hell, this is just a 2. I don't want that long, you know? So it don't like 1s, okay? All right, oh, here we go. Negative 1 times x.
Negative x.
And then here we go. Negative 1 times negative 1.
Positive 1.
Now, I'm going to tell you the biggest mistake I get on pulling. They multiply, 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 then they go negative 1 and negative 1. Oh, that's a 2. They add it because they see all these pluses at the end. So it's all multiplied at that point. Can I go further?
Yeah.
Oh, yeah. What y'all doing?
X squared minus 2x plus 1.
So you basically added those like terms, right? Now, you said minus 2x?
Or plus negative.
Oh, you're good. I'll do the minus. What I didn't want you to do was say plus 2, because a lot of people say, oh, a negative plus a negative is a positive. But that's only when I multiply and divide. My bank don't let me put 2 negatives and make that a positive account. Right? You take a negative out, you take another negative out, it's probably still going to be negative, right? All right, any questions on that yet, y'all, online or in here? So hopefully this is really bringing back the algebra memories. So let's see, let's change it up a little bit. This one gives me an f of x equals negative 18x plus an 8. This one's got a g of x is going to equal x squared plus 5. They want us to find f of 2 plus g of 2. So I wonder what that means. F of 2 plus g of 2.
Would it be like using an exponent?
Does that mean the variable is 2?
The variable is 2. Remember?
Okay.
We said, oh, if they put a number there in place of that x, they want me to take my function and put that 2 in for those x's. But you're on the right track.
Okay, I see what you mean.
So f of 2 plus G of 2 is going to equal my F of 2 plus my G of 2. Now to find F of 2, instead of that being negative 18x, it's going to be negative 18 times 2 plus 8. So here we go, negative 18 times 2 plus 8, because they said, hey, put a 2 in for the x. Same thing on the G, right? Instead of that being x squared, that'll now be 2 squared plus 5, because G said, hey, you're going to put a 2 in for that x. I will say most of the time in the homework, they keep the number the same. So I guess here you are first dabbing into it, I guess. Later on, they might be different, though, okay? So you're going to do order of operations. Y'all remember, please excuse my dear Aunt Sally. Where's she from? Anybody know?
Georgia, right?
Oh, I asked everybody that while going, they missed it. She's from a place really close. Little Rock.
What?
Little Rock. You know why she's from Little Rock? Because you worked last two. Right.
Yeah.
Sometimes you can divide before you add, multiply. Or you can multiply before you divide. It depends on who you get first one. Left. Right, that's why she's from Little Rock. Go ahead and go back to the high schools and tell them, look, y'all right, but we got to put where she's from, okay?
Yeah.
So working the first parentheses and working the second one. Now, I'm going to keep my parentheses until I can get these to a single number each. So in the first one, you're going to multiply first. So what's that? Negative 18 times 2.
Positive 36. 36 positive. Is it 36?
Well, you got negative times positive.
Oh, it's a positive? Oh, yeah, that's negative 36.
So negative 36 and then plus my 8. In the second parentheses, I'm going to hit the exponent first. So 2 squared.
4.
And then plus 5. Now, you know, 2 squared is one you should never miss, because although that exponent means it's 2 times 2, I do got people that are backwards and they'll do 2 times 2 like that. So you ain't going to miss that either way. Now, if that's a 3 squared, you might miss that.
What, how'd you get to 36?
The 36? Oh, so the first thing I had to do inside these parentheses was multiply. That negative 18 times 2. And then over here, the first thing I had to do was the exponent. And y'all want to notice, adding and subtracting is going to be the last thing you do to any kind of a expression like this, okay? So now, you can add negative 36 plus 8. That's going to give me
Negative 18.
Okay. And then you can add the 4 plus 5. All right, y'all, finally, I need to figure out the negative 28 plus 9. Negative 19. I need to hear what you just say. Negative 19? Apparently, huh? All right, y'all, so notice, if they give me letters and no numbers to replace them with, I can only simplify them as far as I can go. If they give me numbers, my God, I better get that down to a single number when I'm done, okay? All right, so I can now do the. So let me try this one, and then I'm going to start doing something with the domain type questions. F of x is going to equal x squared minus 12. G of x is going to equal 11 minus x. They want me to find f times g of n. So y'all, f times g of n, what do they want me to do with that?
We're still doing multiplication, right?
We're still doing multiplication, so we're going to have our f times g of n is going to equal my f of n times my G of n. But what does f of n mean? Well, what did it mean when y'all had an f of 2? You put a number in for the x, right? So what you think this means? What's the f of n?
Switch out the variables. You switch out the variables.
With the
Number.
n. The x is now going to be an n. Remember, whatever's in the parentheses is what gets substituted into those x's. So here, f of n is now going to be n squared minus 12. What about g of n? 11 minus n. So notice, while ago they gave me a 2 to put in for the variable, this one they gave me an n. So it's got to look exactly the same other than those are now n's, okay? And when you put that answer in MATLAB, it better have n's in that answer, not the x's, okay? Oh, so once again, I'm going to, and y'all going to get a lot of practice and I'm falling tonight. Well, y'all got, let's see, Thursday, Friday, Saturday, Sunday. I won't see y'all till Monday. So that's probably a few days to do this little bit. All right, y'all. So here we go. N squared times 11.
11 squared.
N squared times a negative n. So I know that's a negative something.
N cubed.
N cubed. All right, then I got, ooh, this is a pretty good one for Arkansas. Negative 12 times 11.
121.
Oh, 132. So you're
32,
use that 11 times 11, I think. So what'd she say? Negative 132. I'll tell you what's funny about Arkansas. What's 12 times 12?
144.
13 times 13. Because you know why? Because we all quit at 12 times 12 on that thing, right?
Yeah, we did.
We get 12.
That's the difference probably in all the states. We quit at 12. Mississippi probably quits at 10.
Right.
New York, California probably go to 20 or something like that. You
Yeah,
know,
really.
so.
That's crazy.
So we can drag on Mississippi still. All right, y'all, negative 12. Ooh, times a negative n.
Positive 12.
Mm-hmm. Now, that'd probably be the way I put it in, but if you wanted to put it in order, if you wanted it in descending order, you'd go with the negative n to the third plus the 11, what, n squared? Then I'd go to the plus 12n minus 132. And that didn't have no like terms to worry about on it, so we was just able to roll through and go. I can't read that right there. I ain't got no buttons to push. Let's see, TV button. Okay. All right, so we good on that. If they give you f of n, you put an n in. F of 2, you put a 2 in. F of x, you leave it at x. Okay. All right, so I'm going to do some of these like at the end so y'all can see what they mean by all these domains and stuff they're going to ask you. All right, so this one we're given f of x is going to equal x squared. G of x is going to equal 4x minus 7. Let's see what we're asking. Okay, so here's what this one asking. They want to know the domain of the sum of f and g the domain of the difference of f and g. And then finally, the domain of the product of f they actually wanted to find all each of them to find F plus G, F minus G, and F times G. Okay, so we're gonna find operations and then our domains on these, okay? So I'm gonna start with the sum of F and G. So the sum would be F plus G of X equals my F of X plus my G of X. What was F of X? X squared. G of X is a 4X minus 7. They're being added, so can I not just drop all in parentheses? So I'm going to get an X squared plus the 4X minus the 7. All right, so question, can I go further?
Yeah.
No, so I'm stopped as far as I can go. So let's find the domain. And let's see, they're still in set little notation. So here's the question. Do I got any restrictions from F? What's not there? Fraction. So I have no, so that can be any number it can. So I got any restrictions on my G? Because it also has no fractions. So that means my domain is all
Odd numbers.
And you'll find out that if this one's this, the next one's going to be this, and the next one's going to be this. The only one that might be different is if I had division on there, because then I would have that whole function on the bottom. Okay. So what was next? Difference of F and G. So I'm going to do my difference now. So F minus G of X will equal my F minus my G, which is the X squared minus the 4X minus 7. So I'm just going to bring that out to see if there's any restrictions on my final answer. So if we brought that out, what would we get?
X squared plus negative 4X plus 7.
There you go. When he says negative plus a negative 4X, he means subtraction.
If we change all the signs.
Oh, but you did. That was positive. It went to.
Negative, okay.
And that was negative. It went to.
Okay.
But when this, you add ones and third stands, but when it's like, when you find them different, like, subtract ones and third.
So, like this one I went through and I actually was adding them, right? Because this had a positive 1 in there. So if you multiply the positive 1 times 4 would stay 4. And then that 1 times that negative 7 kept it a negative 7. But when you got subtraction, you're going to multiply it like a negative 1. So negative times positive, make that a negative. Negative times negative, make that a positive. So when you drop the in parentheses, if it follows subtraction, you're basically changing all the signs like she was saying. When you bring it out of those parentheses, okay? It's all right at first. We're going to get y'all. I'm having to rehash all those memories about math. Right? So was all y'all like from Little Rock? Little Rock?
I came from Silver Hills, like.
Silver Hills? Yeah, I was there in the 2nd grade. Not Little Rock? Outside the city? Arkansas? Yeah, so that's all Central Arkansas, all right? You probably Little Rock. North Little Rock. Little Rock, so. Yeah. I come out of Little Rock. So we got 1 hour here.
Where'd you go to high school? Where'd you go to high school?
Little Rock Mills. Back before it was whatever it is now. It wasn't is it university studies or something now? Or a magnet school or something back when I went? It was just way out there at Dixon Road. Sweet home Arkansas, y'all. The biggest thing we ever did was throw marshmallows on McClellan High School back in the 80s. The sad thing about it, all the green and yellow marshmallows didn't hit McClellan. They hit the Safeway right down the road on Garner Springs and Baseline.
Oh,
Is that still a Kroger there? Any up in Southwest yet? We trade hell out in that area, Paul.
They do now.
They probably still do, huh? They used to be our cruising road. Let me see if we got any more that can trick y'all up here. All right, so this will be my last one. So this will be f of x is going to equal 4x minus 5. G of x is going to equal 5x minus 35. All I'm going to do is determine the domain of f divided by g of x. And they actually go f of x divided by g of x. All right, so we know f divided by g of x is our f of x over our g of x, which is going to equal on top, what was my f? The 4x minus 5. Now remember, since this is a fraction, it's understood that we got parentheses on top and bottom. But if you put them in the calculator to ever do those kind of problems, you better physically put those parentheses, okay? All right, what was my bottom? Where do you go? 5x minus 35. So to find this domain, is there anything I'm worried about?
Yeah.
Yes, because this does look like a fraction. So since it looks like a fraction, what are you doing?
Setting it equal to 0.
So we want to take that 5x minus 35. And we said it cannot equal 0. So then you're going to solve that for me. Add 35. So you said, so you must have divided both these by 5? All right, so my answer is going to be x such that x is a real number and x
Not equal to 7.
remember, use that not equals. So make that not equal to 7. Because if you put an x equals 7, it's going to think that's the only answer it can take. Is it's a real number and it has to equal 7. So, but y'all going to get used to those when you're going through there, and you'll see when you're doing them. It'll give you one with the equals and without the not equals, and then it might even throw a greater than or less than type stuff at you to throw curveballs at you. But on these, you only got 2 answers. It's either all real numbers or it's all real numbers except for this one number. Okay. So y'all, any questions on this? So the main thing is get back in practice doing your foiling. You're adding like terms. So this week, by Sunday night, the only things that we do is up to this 8-4. When we come back, it goes from 8-4, from 2-4, I think we jump into 9-1, but it's because it's more algebra type stuff. I think next week is 9-1 and 9-2, and then we do all the 3 stuff after. So we sort of skip around, but that's to keep us from having to do this now and then doing it again later and then doing it again later. We try to group it all together, you know. So y'all, anyone got questions online?
I'm good.
Well, the thing about that picture is it'll only show what like if I wanted that to show us again, let me see. All right, y'all hang on 1 second. I would have to pull it out and then pull it back in. And it pulls different people up because I don't have nothing on screen other than them. So I'm gonna stop that share on that screen. I told you that. So, but see, I can't pull nothing up back there. Oh, well. All right, so no questions? All right, y'all, so up to 2.4, knock out 2.4 by Sunday night. Monday, we'll knock out 9.1, start rolling, okay? So we should be pretty much back on schedule now because I did the 2 short sections Monday and that first one today. So we should be actually back on schedule with the due dates. But Math Lab is more accurate on anything than Blackboard is. If you want your most accurate grade, it's in Math Lab. Y'all might do one homework problem in Math Lab, and it might change your grade from a 50 to an 80. It takes a little bit to sync it over to Blackboard. So if you get out in homework, go to Blackboard and say, oh, damn, I just did that, but it ain't giving me credit. It's still showing a 50. No, it ain't. It just ain't synced over yet. Sometimes it takes it an hour or two just to sync them over. So if you want your most accurate grade, go into where you find the assignments, and there should be a link that says My Labs Student Grade Book or something. Click on that, and it'll be the most accurate grade of all, okay? Now, as far as dropping the low stuff, I don't do that until the very end, okay? All right, y'all, so I'm going to quit this recording, and I will send this out.